collaborating since long. So, so far we have seen so many technologies. We have understood SD-WAN, we have understood cloud delivered, Zscaler service. We have seen, cloud delivered Prisma Access service, right? So we have seen all these technologies, and multiple times we have discussed about cloud, right, in between. Okay. So first we need to understand why do we need cloud? Okay, why there was a need, and uh, okay, so we need to understand why you know cloud got invented, what was the need, right, and how it is beneficial for the organizations, right? So if you understand cloud in a nutshell, it's quite straightforward. Okay, quite straightforward in a sense that if you see earlier, we used to have data centers on premise, right? So everything we used to have on premise, we were putting up the servers, we were building up the infrastructures, right? And it was catering our user load, you can say, right? So let's take an example. We are Hotstar, right? And we have built everything on premise. These are servers, and all the servers are in our data center, right? Now, the capacity of these servers can handle 1 million users, right? So, on an average, if I see my usage throughout the year, my usage is less than 1 million. So, this is the user count 1 million. This is the maximum capacity my data center can handle. And my user count is like this. But suddenly, uh, you can say there is a match, India Pakistan match is there, and user count just spiked, right? It is crossing 1 million. The moment it is going to cross this particular 1 million bar, you will have degraded performance. Okay. And there will be problem in the streaming. Okay. And then once the load will go down, everything will back to normal, right? Now this spike, which is letting your servers go beyond 1 million, is something which is demanding more compute power in your data centers. Now, let's take an example. Throughout the year, build 1 million user support. I'm paying $10,000 for my physical data center, right? Now, during this spike, I noticed that user count went to 2 million. It just went double. So now, cater that, I need to have more capacity in my data centers, and it's seems like that we need to just double the compute. So we have to make it $20,000 investment. These numbers are just just for reference to cater 2 million hit count for future reference, and this will also depend on the occasion or a particular event, right? It is not continuous. If you see the cost that I need to invest 10,000 more just to keep in my mind that on a particular event on a particular day I'll see a user spike of 2 million, right? So economically, it is not good. Okay? That's why, clouds, they come into the picture because they offer the model like pay as you go. Now, this model, pay as you go, means that whatever you're using, you have to pay for that only. Okay. Your resources can be auto scale, they can be auto scale up, they can be auto scale down. Right. So whenever there is a demand, your servers will increase the throughput. You will be able to handle more load. And if your demand is decreasing, then the load will be decreased on your servers accordingly, right? You will be charged for whatever time period you have consumed more resources. Accordingly, you will be charged, right? So this has given the flexibility to the organizations like Hotstar or Netflix, who are streaming the services, streaming the video, right? Because video streaming is one of the most, you can say, bandwidth consuming service, and it is like something which requires more bandwidth, more usage, right? Compute should be available. So whosoever is providing streaming services, they often like to go on cloud services so that it can auto scale, auto down, and billing can be adjusted as per the usage. In fact, for us as well, we are also using cloud resources, okay, to stream the videos. Now, why cloud? Right? What made industry to move towards cloud? So one reason was this, where on-premise limitations were coming, right? Another thing was like redundancy. If you see today, now if you're a multinational company, multi-region presence is there, right? So you can have multiple data centers across the globe, right? But there is a cost associated with it, right? DCDR you have to build for failovers, right? If something goes wrong with DC, so your services should automatically switch over to DR, right? So you have to build the redundancy, you have to pay for the underlays, you have to pay for the P2P links between the DCDR, right? For synchronization between the servers, right? And you have to also pay for the extra hardware which you are keeping it in your DR, right? So ultimately, if you see the cost, it is becoming more as compared to cloud deployment. Because in cloud, you get redundancy, right? You can build your resources in one region, then backup you can create in another region. You don't need any manpower to maintain the physical servers. You don't need any electricity related maintenance, right? You need not to worry about the power maintenance, right? So basically what is happening, it's like someone has created a renting model. It is simple a renting model, right? So initially what happened was like Amazon, what they did, they created this particular Amazon Web Services. I mean, after developing the platform for themselves. Basically, what happened was like Amazon, we all know it is an e-commerce website, right? We all use it. So basically, Amazon was building the uh, you know infrastructure for itself for its website, right? Later on, they discovered that this infrastructure can be rented out, right? Because they have developed in a way that it is efficiently using the servers, it is efficiently using the resources. So basically, what happened is like we all know traditional networking that we have racks, we place in our servers, server 1, server 2, server 3, server 4. Then we have our networking devices. We have switch, right? We have firewall, we have router, and then we have ISP mux, right? This is how your rack looks like. Now here, each device, let's take an example. These are Dell servers. They have their own management software. Let's take an example. This is Cisco switch. It has its own manageability, console or GUI. Let's say this is Palo Alto firewall. It is having its own UI, right? Cisco router. And then this is Huawei Mux, right? Now, throughout the rack, we have so many devices. And they are coming from the different vendors, right? They have their own management softwares. The way they are deployed, it's different. So what Amazon did, they created a software, or you can say a OS layer, which is helping you to build everything virtually by using the underlay hardware, right? Now in cloud, we call these hardwares as white boxes. So white boxes means that hardware could be from any OEM. I can install any OS on top of it, and that particular box will start behaving like that. Let's take an example on these Dell server. I can spin up router image. I can spin up switch image. I can spin up firewall image. I can spin up my servers, whatever I want, right? So these boxes, they become white box in cloud term. So basically what Amazon did, let's take an example. Amazon today is having multiple locations across the globe, multiple data centers are there, where we have these racks, where these servers are available, right? Now, with the help of the OS, that is your Amazon OS, which helps it to use it in a better way, and you can build your policies virtually, you can deploy your services virtually. So basically, what happens, it's like these are hyperscalers, Amazon, Azure, Google Cloud, right? These are hyperscalers. We call them hyperscalers. Now, for them to expand across the globe, it's not that easy, right? They cannot have data centers in every country. Then how they have expanded themselves so quickly, right? How Amazon is today having presence in every country, most, I mean, in most major countries, right? How it is happening. So what they did is like they tie up with local ISPs of that particular country, right? Now your ISP is already having a network within your country. If you see, if I will take example of India, so we have two big players in India, right? Tata and Airtel. Now Tata is having data centers in Delhi. Tata is having data center in Mumbai. Tata is having data center in Chennai. Tata is having data center in Pune, right? Similarly in Hyderabad. I mean, there are a couple of locations where the data centers are available. In fact, across the globe, these are major pops. Then we have mini pops, right? So Tata is having presence across India. Now, if I want to launch my services, right? First option is like I will build up my facility. It will take time. It will need investment, right? Being a hyperscaler, I just want to launch my nodes as soon as possible. So what I'm gonna do is like I'm gonna rent out space from these ISPs. I'm gonna take co-location, colo we call it. I'm gonna rent out the space for my racks. I'll pay for it, right? So there is an entire process how we do that, right? We are not going to discuss about it. Now, why I am deploying my racks in the ISP data center? The reason being that you also get internet connectivity. It is going to reduce the latency. Okay. So when I'm renting out the space in the ISPs, I get internet connectivity, high bandwidths are there because there will be no need to do the feasibility for my last mile, right? Because you need to buy the underlay circuit. You need to make your servers live over internet. So these are public clouds. So basically, we need to understand first how many hyperscalers are there in the market, which are the major leaders. So in the list, we have AWS, we have Azure, and we have Google. And now, Oracle is also taking the share. Okay. Amazon, first mover advantage, then Azure, and now Google is also doing good. It didn't perform well initially, but now it is also uh, doing good. And Oracle is also, in the race now, right? And there are so many other players are also there, right? Now these are the hyperscalers which are like well known. Now, if you see that AWS, Azure, and Google, they are well known. What about others? Have you ever worked on Oracle? Have you ever worked on any normal private cloud service provider? Right? There are many. I know many brands in India, right? So it's like that. Uh, you know, if you do the cost comparison between the services, right? So it depends on your use case, and accordingly you buy the services. Okay. Now there is a concept of private cloud and public cloud. So first of all, we have understood what is cloud. So cloud is like the resources are available on a centralized data center location which can be accessed from anywhere, right? So it's like if I'm keeping my data on cloud, I can access it from anywhere. Okay, because it is available over internet if it is a public cloud, right? If it is a private cloud, then I would need some sort of connectivity, private connectivity, so that I can access my resources. So basically, cloud is like you're not doing computing locally, right? Rather, you're doing computing somewhere else. Okay. So you have your users, you have your devices, right? They are getting application access on a resource which is hosted somewhere else, right? It is available in some other premise. If it is private, it could be your property, but if it is public, then you are using it and you are paying as per your usage. That is pay as you go model. Okay. Now, private cloud, it's like companies, they are having their own private data centers, putting up the resources, right? And that particular cloud is being only used for the particular organization. It is not shared with others. A public cloud is like it is available over internet, it is shareable, the resources are getting shared with others. Although you get the virtualized container environment where your applications, your services are not interfering with others, right? So you get that particular infrastructure, okay? And within this private and public, we have different models, right? So if you see the offering, the services which we get from the cloud, very first thing is like infrastructure as a service, platform as a service, and software as a service. So infrastructure as a service, it's like that I built up the entire rack and I'm giving you as an infrastructure. and then on top of it, you're building your services and you're further giving it to your end customer. Typical example, or you can say the perfect example, Zscaler. Do you think Zscaler has all the data centers on their private premise? No, they're using it on the hyperscalers, right? So hyperscalers themselves are renting out the space of the ISPs within the country, and then they're giving that particular infrastructure to someone else, and then that someone else company is building their services on that particular infrastructure and then giving it to you. So this is how it is going, right? A platform as a service, it's like when you build something, you are creating a platform and then you are sharing it with others, right? Software as a service, it's like I have built the software and now I'm giving it to you. So Zscaler, when it comes to the end customer, it's a software as a service. If Cloudx is today, Ngcloudx is today using Zscaler. So for me, it is SaaS, software as a service, right? And if Zscaler is using infrastructure of AWS, then for Zscaler, it is infrastructure as a service and AWS is taking the money, right? So AWS is charging Zscaler for infrastructure as a service, and Zscaler is charging the end customer for software as a service, right? So it depends that who is the party, who is buying services from where, right? So basically, this cloud is helping you to use your resources efficiently, right? If you have subscribed to our labs, whosoever has taken the lab subscription, now what is that, right? It is a private cloud where virtually you can build your topology and you get internet connectivity and you can do your labs. You can spin up any OS, you can build your topology, right, in our emulators. And irrespective of underlay connectivity, right, your labs are always up. So basically what happens in the actual environment is like whosoever is providing you the cloud services, they will ensure that multiple underlays are available. So you need not to worry about the ISP underlays, right? If I'm a cloud provider, I'm having multiple underlays. This is Tata Link. This is Airtel. I might have Sifi, right? But whosoever is using AWS cloud and they're building their, complete infrastructure, for them, they just need to attach one service that is internet gateway and they are done. That service will give them the internet access, irrespective of the actual underlay which is being used. Now, any underlay can go down anytime, right? But AWS will ensure 100% uptime. Now, this is another thing, guys. Whenever we host any application, we need to ensure 100% uptime. If you have seen earlier, we were facing challenges with Ngcloudx website itself. When I was using third-party services, I used to face streaming related problems, website availability related problems. Then we switched to our own premise setup and we deployed everything on our on-premise devices. Then again, ISP related issues were coming and I was struggling to give you 100% uptime. But the moment I went on cloud, now everything is 100% uptime, right? So cloud is giving you redundancy. Cloud is ensuring that your application is reachable, is live over internet 100%, right? And it's like, although the cost comparison, if I do, it's quite expensive, right? If I compare it with my own prem. because it depends on, use case to use case. I'm not that big organization where I need to have multi-region data centers, right? I could have one data center at one location, and it could have solved my problem. But to ensure 100% uptime, I want to, I have to go to cloud. Or what I have done today is like I'm using hybrid model. So it's like on-prem setup and cloud setup combined. Combinedly it is getting utilized to optimize the cost and to ensure the 100% uptime, right? And DC-DR is also there. So DC is in cloud, DR is on-prem. So you will see hybrid deployments. You will see complete cloud deployments, right? So it all depends on your infrastructure, on your requirement. These days, I'm seeing organizations, especially startups, they don't invest in initial cloud building or initial, you can say, on-premise infrastructure. They rather go on clouds, right? If today you pick any particular company which is providing you software as a service, if you check their infrastructure, you will find it out either they are using AWS or they are using Azure or they are using GCP, right? So mainly all these startups, they build up everything on cloud and then they scale up, right? Now we have understood the utilization of the cloud, we have understood the concept. Now it's like, what is AWS, right? So AWS is your Amazon Web Services, where you can build your infrastructure from scratch and you can host your services. Okay. Now, before starting AWS, we need to understand two architecture of the application development, right? So the very first architecture is monolithic architecture, which was the traditional architecture and it is being used initially. Then we switched to microservices based architecture. Okay. So what is monolithic? Monolithic, it's like that you're building one system. If I'll take the reference of my website only, my application, so that it will make more sense for you to understand it in a better way. So yeah. So monolithic, it's like I have built one system and the system is my streaming platform, right? Where I'm having streaming service, I'm having payment gateway service, I'm having certificate related service, I'm having continuously, authentication monitoring service, and multiple other services are there. By using them, I'm calling it out as Ngcloudx. That this is my offering, right? Whatever I have implemented in the backend, there are multiple components which are there, which are serving you the courses, which are giving you the courses, right? Now, this is the overall system. Now, if any service component is going to fail, the entire system will go down. You will get service unavailable, right? Because in monolithic architecture, your entire infrastructure is tied up with the services. If any service fails, your entire system will go down. Your payment can have issue. If something is wrong with your payment gateway service, you'll face issue with your overall services, right? Your streaming will also stop. User won't be able to log in. User won't be able to do anything on the website. Everything will go down. If something goes wrong with the backend, right, in a monolithic architecture, so entire web property will go down. On the other hand, because we have database services here, backend services here, right? So many transactions are happening. On the other hand, if you switch to microservices architecture, where all these services are running independently and making a system. So let's take an example in microservices. You have database services, you have database service, you have payment service, payment gateway service, you have streaming service, you have authentication service, right? Now, if any one of them goes down, depending on the critical nature of that particular service, let's take an example, payment has failed. It is not going to bring down your entire application. Your application will be up. It is just that user won't be able to make any payment for the new enrollment, but they will be able to watch the courses, right? If something is wrong with the streaming, you can enroll to the courses, but you are not able to watch it. That is a different story, but at least you can buy the courses. So in microservices architecture of the applications, you are not losing your entire application because of the service failures. And why service fails, because continuously developers are making changes in the code, right? They are doing something in the code. Sometimes errors, sometimes logical problems in the code, and it brings down the system, right? It brings down that particular service. Now, these microservices, the best part is like you can host it on different clouds and you can integrate it and you can make it a multi-cloud architecture and multi-cloud application. Let's take an example. In Azure, we have AWS, we have Oracle, right? So it might be possible that for front end, I'm using AWS. For backend, because I'm using .NET, I'm using Azure. And for database, I'm using Oracle Cloud. Earlier in monolithic, I have to have it on my premise, right? The architecture should be like front end server should be there, backend should be there, database should be there, and then the communication should be there between them. So it's like we have front end and DMZ, that is your web server, which interacts with the users. So we are placing it inside the DMZ, right? Then we have our backend in MZ, right? Our databases, they are also in MZ, right? And transactions are happening between the servers, right? And your application is working, and then payment services. So many things are there, right? When the setup was on premise. When you're going on cloud, on microservices, then you can use the microservices from different hyperscalers and you can integrate it together and it will become a multi-cloud. This multi-cloud connect is from Tata, sorry. This is a different product. So this will become multi-cloud based microservice application, right? So there will be cloud networking, and this is where this product comes into the picture from Tatacom, multi-cloud connect, right? It's not like that the setup which you have on-prem, you cannot have the same set of infrastructure in particular one of the cloud. You can have it. Same structure, I can build it in AWS. There will be different terms. There will be different ways of doing it, right? So since now we have started with AWS, so we'll talk more on AWS. We'll understand the components, the services which we have and which we will be using in the training commonly. So very first thing you need to understand is your EC2 instance. What is EC2 instance in AWS, right? So basically, this is a machine where you can load up any OS and it will become that particular machine. So let's take an example. I want to deploy one web server, right? And this web server should use Ubuntu server OS. This is what I want, right? And what I'm gonna do is like in AWS, I'm gonna pick up one EC2 instance. Now I need to do sizing that how big server I need, whether I need micro server, I need mini, I need small, medium, large, extra large, right? So basically the sizing, it's like how much compute you want to give to that server. 2 vCPU, 4 vCPU. I'm just taking references. Right now it is not a correct. I'll give you the correct sizing of the instances. 8 vCPU, right? And accordingly the RAM. Let's take an example. This is 2 GB. This is 4 GB. This is 8 GB. Like that, right? How much big machine you need, right? So accordingly, you will pick up the size of your instance and then you load this particular OS on top of it. And when the deployment is done, your virtual machine is ready as Ubuntu server and you can use it as Ubuntu server. Later on, if you don't want it, you can delete it. You can spin up Windows server. You can spin up any firewall image, Palo Alto, Checkpoint, whatever you want, right? So EC2 instance helps you to spin up your virtual machines in AWS environment, right? Then we have another important, interesting term that is VPC, right? We do have subnets because cloud networking is also there, right? So VPC is there, subnets is there. Then, the common terms, internet gateway, right? Uh, application load balancer, network load balancer, right? Um, VPN gateway, transit gateway, right? S3 bucket. So many things are there. I mean, so many services, so many, all these are services. VPN gateway, transit gateway, S3 bucket, network load balancer, application load balancer, internet gateway, right? These two things, VPC and subnet, it will help you to build your topology in cloud. The way we do it physically, that we stack up our rack stack our servers, rack stack our switches, routers, right? We do the networking and then it becomes online. Similarly, with the help of VPC and subnets, you're going to build up your topology in the cloud, right? And then there will be multiple services which you are going to use, make that topology live over cloud, right? So normally what we do as per the best practices, from security point of view, because so far we have been understanding security only, cyber security. So you have production VPC, where you keep all of your servers, all your resources, and then you have security VPC, where you keep your firewalls, right? And then you ensure the connectivity between these VPCs. So earlier we used to do the VPC peering, but now we make use of transit gateway. So we'll discuss about everything in detail. We'll understand everything, right? So in this training, what I'm going to cover is like, we'll do the complete deployment of a mini data center, not a data center, but yeah, a particular production environment. We'll try to deploy it in AWS, and we'll understand everything from end to end, right? We'll deploy the web servers, we'll deploy the other services like application load balancer, network load balancer, VPN gateway, transit gateway, right? We'll create the security VPC. We'll try to secure our infrastructure. Okay. We'll use the checkpoint firewalls here. Okay. Because checkpoint firewalls, they come up with the evaluation license. So we will be able to do it in a better way. Okay. So all of these things we are going to do it to build our complete topology, right? And it will help us to host our services. So basically what I'm going to do is like, I'm going to make one website online, which I'm going to deploy it in AWS by using the AWS components and services. And I'll secure it with the help of the checkpoint firewalls. Okay. Now, how AWS console looks like. So this is how it looks like. Okay. This is your Amazon console, where if you see, if you click on console home, so it will show you that if you have any applications recently, what you have visited in the AWS, right? Your cost, right? AWS health and all that stuff. Basically, this is the home which you have. But if you go here, if I want EC2 instance, right? Then here you will see the dashboard, how many instances are running, dedicated host, elastic IPs, auto scaling groups, capacity reservations, right? Load balancers, key pairs, security groups. So all of these things we will discuss and we will understand. Okay? Because then only you will be able to build up your topology. And I'll also show you that how to build the network diagrams in AWS, because it is quite important, right? Without diagrams, you won't be able to understand how things are working. Private subnets, public subnets, security VPC, production VPC, and then peering between them, and what services you need to use, right? And if you are doing the transformation from legacy environment to new, because there are migrations going on in cloud as well. Because earlier clouds were built by using the cloud, legacy cloud services, right? But now people are doing transformations. Earlier, people were not, I mean, industry was not using firewalls in the cloud, but now they are using firewalls. They're deploying Palo Alto, they're deploying Checkpoint. How to do that? Because if you have already created an entire infrastructure in cloud, how you will ensure that your traffic will be, redirected via firewall towards your resources? So gateway load balancers are there, right? Transit gateway is there. There are multiple ways you can redirect your traffic, and the way we do the networking and configurations in cloud is quite different from the traditional methods which we do it on-premise setup. Okay, so gateway load balancers are there, transit gateways are there, right? And those architectures are quite important, because what I've seen so far, it's like since I have left the job and doing this business full time, In the market, people don't know how to do cloud transformation. Huge potential is there, right? Since then, it's been 1 year. I'm doing this full time. I have done more than 10 cloud transformations for my customers, for 10 different customers, right? Where we have deployed Palo Alto firewalls, where we have deployed Checkpoint firewalls. Customers or the SIs who were involved in the transformation, they were not aware how to redesign the traffic flow, the cloud. Because let's take an example, your customer is already having a complete network built up in the cloud, and now you are selling them the firewalls. So how you are going to redesign their infrastructure, how you're going to, in fact, redesign if you're selling them SD-WAN, because I have done it multiple times before. My data centers are in AWS. My branches are on different locations of India. And I want to have a secure fabric built up between my branches and my cloud. SD-WAN fabric I want to build up. How you're going to do that transformation? Right? Because there are so many things which can be utilized to connect to these cloud environments, right? We do have private connects, we do have direct connects, right? If you have MPLS and all. So all of these things we are going to discuss in this particular training, right? I'll release the course curriculum as well. And what are the points and things which we will be covering. On top of it, we will do the real-time deployment as well, right? So that I can show you that how you can build up on particular environment where you have the firewalls, you have your servers, and entire traffic is getting inspected through firewalls, right? So greenfield deployments are always easy, but things become interesting when you're doing brownfield migrations where your production was already up and you have to do the transformation in that particular case. How you are going to introduce the firewalls, which particular service you're going to use it to redirect the traffic, and how you will ensure that it is not going to break the application flow. And then in cloud, EKS cluster is there, Docker is there, right? So we need to also have some basic understanding of Docker, Kubernetes, EKS cluster, how these technologies work, right? And how it is going to ensure that when we are doing the transformation, application flow is not going to be broken, right? So the dashboard looks like this, and then you will see the AMIs. So these are the images, the guest OS which I was talking about, right? So you have the catalog where you can search for your OS, and you can spin up on that particular EC2 instance, and that EC2 instance will become that particular product. Okay. So if you see, now I need not to worry about the underlying hardware, that what sort of brand hardware I have, Dell, HP, whatever it is, right? I don't even care. I just need one EC2 instance. I need a small machine. I need a big machine. I'll just allocate it. I'll spin up my OS on top of it, and I'm good, right? So this is what it is. This is what cloud is helping you to achieve. Okay. Now, similarly here, if you scroll it down, you will see network and security. Here, you will see the security groups. You will see the elastic IPs, key pairs, network interfaces. Then in load balancing, you will see the load balancers, right? In auto scaling group, you will see the scaling features. All of these things are coming up, right? Similarly, we will create our VPC. So here, if you see, this is your VPC. So we'll create the VPC, we'll select the region that where you would like to deploy your VPC, right? You'll create your subnets, you'll create your route tables, internet gateways, NAT gateways, VPC peering connections, right? So all of these things are available to us, and we have to understand it, right? So when we are going to, you can say, build the entire topology from scratch, it will give you that confidence that you will understand how this exactly how AWS infrastructure based data centers work, right? We do have native firewalls available from the cloud providers, right? And you can use third party OEM firewalls like Checkpoint, Palo Alto, and all that. And whenever we go in the market, we have metal cards available that why you should use Checkpoint, why you should use Palo Alto, right? Why we should not be using native cloud firewall, what features you will be missing out there, and all that stuff. So site-to-site capabilities, VPN capabilities, so many things are available. Then we have this transit gateway, right? Traffic mirroring. So if you see, whatever you can do on premise, you can do in cloud as well. Okay? The terms are different. The way of doing it is different. So best part to proceed with cloud is like first you should have your network diagram ready. Okay. So first you need to build your network topology. That how the flow is going to look like, right? So first we'll start with very basic topology where we'll create one VPC, we'll allocate our public private subnets, we'll spin up one server, and then we are trying to access it from outside, right? And whatever things are needed, we'll see that, right? And then slowly and gradually we'll keep on adding the components to make that topology look like a clone of production, right? So to do that, we will also keep focusing on the diagrams, right? That how to design, what tools you must be using to design these architectures, where you will get these stencils, right? Because you need stencils if you are building the design for your AWS, right? So you need to use the stencils or icons of the AWS services. You cannot use it of Azure, right? So this is what we are going to cover in this particular course. If you have any doubt, anything, just let me know. Because today was just the introduction class, right? That what is AWS, right? How to build it and all that stuff. So I'll just stop my